Here we're asked to verify an identity. So we're going to take this identity and we're going to make a 2-column table here. We're going to put a statement of what we are doing, and then we are going to give a rationale why we can do that. And typically you would start with the more complicated side. If the sides are about the same, like this one, it doesn't matter which side. So I'm going to start with the left-hand side, which is 1 minus sine to the 4th x, and I'm just going to write LHS for meaning I picked the left-hand side. Now looking at that left-hand side, I can see it's the difference of squares, so I'm going to factor it. That's going to be 1 plus sine squared x and 1 minus sine squared x, and that's by factoring. And you can just write factoring if you want, or you could write factoring difference of squares if you wanted to. Now, as I'm looking to see what I could do in this next step, I recognize this because this shows up a lot. It's a Pythagorean identity. The Pythagorean identity, the fundamental identity solved for cosine squared, and that is 1 minus. I'm just writing it up here. You don't need to do this on here, but just for you guys to see. So I can replace 1 minus sine squared with cosine squared. So I'm going to do that in this next step. And so that's going to be 1 plus sine squared x times cosine squared x. And that is using the Pythagorean identity. Okay. Now, seeing as I'm headed towards trying to show that it equals the right-hand side, and the right-hand side is only cosines, then what I think I'm going to do in this next step is replace this sine squared using the Pythagorean identity. So the Pythagorean identity for sine squared is 1 minus cosine squared x. That way I would have it in terms of cosines. So I'm going to have 1 on the front, and then replace this sine squared x with 1 minus cosine squared x, and then I still have this cosine squared x. So my rationale there is I use the Pythagorean identity again, and if you want to, you can abbreviate it like this, and I did ID for identity in it. I would know what you mean. Okay, so then I'm going to simplify. So the 1 plus 1 is just going to give me 2 minus cosine squared x, and then we still have this cosine squared x, and all I did there was addition. I just added those two together. Okay, now the next thing I'm going to do is I'm wanting it to look like this, where there's no parentheses, it's just two different cosine terms, so I'm going to distribute. It's on the end instead of the front, but we distribute the same way. So I'm going to do, I'm just going to write distribute. That's what I'm doing right here. And so the first term will be 2 cosine squared x, and then minus, and cosine squared is a cosine to the 4th x. And we see that that matches what we were headed for. It equals the right-hand side. So now I'm done.